Hi everyone. In this video, we're going to be answering questions from two different topics. Number one is light, and then I think the next one is pressure. So there'll be five questions altogether in this video, and then in the final video, we'll talk about another topic. So in this first question, we get this situation where 9.1 shows a blind spot mirror installed on the side mirror of a vehicle, for the driver to view the blind corner to reduce the rate of accidents. So, of course, the significant difference between the vehicle side mirror and the blind spot mirror is generally the vehicle side mirror is a plane mirror. Manakala, the blind spot mirror is a convex mirror. And the convex mirror usually has a very important function. So before we actually go into the question, just to remind you of the essential things about mirrors, which is that when you talk about convex mirror, when you talk about convex mirror, the important feature of the convex mirror is that it has a wide field of vision. You can see more things now. But the downside to it is, if it's a downside, the images are diminished. As opposed to the concave mirror, the concave mirror has a smaller field of vision. But the good thing is the images are generally, magnified. Which is what makes the convex mirror suitable for security mirrors. Security mirrors, or another one is we call safety mirrors, the ones that you see at the corner of the road, or even in the case of this question now, which is the side, the blind side mirror. The idea is so that you can see more, but everything is much less. In the case of a concave mirror, most of the time concave mirror is makeup mirror. The mirror that you use for makeup, or in the one in your compact. So the mirror, dia masuk ke dalam kan, so it's a concave mirror. Of course, another one is the dentist. Dentist mirror also lah. The one that looks like a spoon and then put inside your mouth to see what's happening with where the cavities are and everything. So this is the general feature of the convex and the concave mirror. And then of course, when you talk about the characteristics of the image, all depends on where the distances are. So in the case of a mirror, if let's say this is the focal length, f. So and let's say the focal length is 10 centimeters. So 2f for the mirror, obviously it will be another 10 centimeters. And also the fact of the matter is that the fact of the matter is that the 2f in the mirror is also known as the C, which is the center of curvature. Now depending on where the object is, so this particular object here is U is more than 2f because it's beyond the 2f. In the second case, if this one will be U equals to 2f. Means ngam at the center of curvature. And then the third case will be somewhere over here. This will be U equals, this one is a little bit special. This is U is in between F and 2F. That's how it's written. That's how it's mentioned. But I guess you can say F is less than U is less than 2F lah. I mean, either way lah. But either way is the object is between F and 2F. Fourth case is ngam here. U is equals to F. This is the fourth case. And in the fifth case, the fifth and the final one is this. U is less than F. Means U is less than the focal length. Less than 10 cm lah, obviously lah. This is less than 10 cm. Now, these five positions, will give you different image lah. Okay, we'll give you a different image, and how we remember the image is with this. Okay, position 1 will give you read. Okay, the green color over here. Okay, so this one will give you this image read. Okay, and then so this will be read, and then the second one will be Reese. Okay, this is okay Reese, and then the third one, oh no, sorry, the third one is this. Okay, the third one is rim. Okay, means if you put the position there, the image will be rim. Okay, I'll talk about this rim in a while. Okay, and then of course the fourth one is U is equals to F. So when you get U equals to F, the image is boom. And then finally U is less than F. This one, the image will be boom. Okay, so how you remember this will be read, raise, rim, boom, boom. Okay, and so read means is rail inverted, diminish. Okay, so it's rail, it's inverted, okay, is diminished. That's read lah. Okay, and then raise will be rail inverted and same size. That's raise. Okay, and then rim is rail inverted and magnified. Okay, and then of course you're left with the VU and M lah. Voom. M is magnified, V is virtual. Okay, and then the last one is upright. Okay, so usually you want to remember the positions and the image. Just remember that read, raise, rim, boom, boom. Okay, so remember it in this one. Okay, read, raise, rim, boom, boom. Except that the first boom, U is equals to F, is a little bit special. I know it's called virtual upright magnified, but another feature of it is that it forms at infinity. Okay, so that's a very important feature. Now, the good news about this is for both the concave mirror and the convex lens, they have the exact same characteristics of the image. Okay, so concave mirror and convex lens. Okay, the read, raise, rim, boom, boom, okay, applies. Okay, at the same positions. Okay, so even in the lens in this case, this will be read because it's beyond the 2F. This is raise, this is rim, this is boom, this is boom. But of course, this boom is at infinity. Okay, that means if let's say let's say I'm talking about this particular object, it'll be RID, bahkan rail inverted diminish. Okay, so it'll be somewhere along here. The image will be here. Okay, it's a rail image because it forms behind the lens. Okay, and it's an inverted image because it goes downwards and it's smaller size. Okay, so that's how you want to remember the characteristics of the image. Because this is a very important question lah. Okay, usually in paper 1 also they will ask this. Of course, you also need to know that one big difference between the lens and the mirror is that in the lens, the real image is formed behind the lens. Okay, on the opposite side of the object. Manakala virtual will be on the same side as the object. But mirror, okay, because it's a reflection situation, so a real image will form in the same side of the object in front of the mirror, and the virtual image will be formed inside the mirror. Okay, well, yeah, inside the mirror, okay, in that sense. So, if this is a bit too fast for you, you can always, rewind back and watch it again. But having this foundation makes this chapter very, very easy because both the convex lens and the concave mirror have the exact same image characteristics at the exact same object distances. Okay, it's just read, raise, rim, boom, boom. Okay, rail, inverted, diminish, etc., etc., etc. Okay, so one very important application of this is this. Let's say I say that the focal length is 10 cm. Okay, and then I position my object at 25 cm. Okay, my object distance is 25 cm. I put it in front of whatever concave mirror or convex lens. Same thing. Okay, when you know the focal length and you know the object distance, you can immediately tell me what is the characteristics of the image. Oh, okay. If f is 10 centimeters, 2f is 20 centimeters. My object distance is bigger than 2f. Bigger than 2f means what? It will be read. Okay, my image characteristics will be rail, inverted, diminished. Likewise, if let's say, now I change this question lah. Let's say my object distance now is let's say 12 cm. Okay, so it's less than 2f, but it's more than f. So we're talking about situation number 3, between f and 2f. So what is situation 3 punya characteristics of the image? It will be real, inverted, magnified. So remember this, because it's too easy not to remember. Okay, read, raise, rim, boom, boom. You just have to make sure that you grasp the concept of the focal length and of course the object distances correctly. Okay, now, so this one is concave mirror and convex lens. Now the good news is with the convex mirror and the concave lens, okay, with these two situations, no matter where the object is, okay, U is wherever, the characteristics of the image is always the same. It's always virtual, upright, diminished. Okay, whether it's convex mirror or concave lens, no matter where you put the object, the image will always be virtual, will always be upright, will always be diminished. And this is the only time where you will see VUD. You don't see VUD here. It's read, ring, boom, boom, right? You don't see VUD. Okay, the only time you see VUD is when you use convex mirror and concave lens. Okay, so you have to remember this as a set. Okay, coming back to the question. So what is the phenomena involved in the formation of the image of the mirror? Obviously, this is reflection lah. Okay, because in lens, the phenomena involved is refraction. Okay, copy diagram 9.2, complete the ray diagram for the blind spot mirror use. Okay, so obviously, the first one is parallel and then, you know, it goes back here, right? So the reflection line should be going towards F. Okay, and then the second one is, since it's going straight into the mirror, it will pass through C. So you know, kind of like draw this over here like that lah. And then the image will be formed over here. Okay, so what is this? This is virtual upright diminish. Okay, virtual upright diminish means this is a convex mirror. Okay, obviously it's a convex mirror because, as I said just now, the only time where it's VUD is that it's convex mirror or concave lens. Okay, so that's how you would get this lah. So 1 mark for every line. Okay, so every line will give you 1 mark. This one will give you 1 mark. This one will give you 1 mark. Goes to C. And then the formation of the image is the 3rd mark. Okay, that's how it will be. Now state one characteristic of the image. You can either state all 3. You can state 1 if you want. But we know that the answer is virtual, upright, diminished. Of course, you don't have. Of course, you cannot write the letters. Now you have to write the full name for it. Okay. Now, table 9 shows the specifications of 4 safety mirrors. Your company was given a project to install road safety mirrors along the road of a busy housing estate. So this is what I was saying just now. Okay, when we want safety mirrors, we want to use convex mirror. Okay, why convex mirror? And as I said just now, when you say convex mirror, the main idea is that it has a wide field of vision. Okay, and this should be the reason. Okay, wide field of vision. You can use wide field of view, you can use wide field of vision. It's essentially the same thing. Okay, the diameter of the curved mirror, okay, should be big, because a bigger diameter of mirror means the mirror is a bigger size lah. Okay, so you can have a brighter image. Okay, you can have a brighter image. Position of mirror should be high, okay, because this is along the road of a busy housing estate lah. You don't put the mirror on the road, put the mirror somewhere high up. Okay, and usually when you put the mirror somewhere high up, will be no obstacles. Okay, there's no obstacles that can be this one lah. Okay, and then of course the reflective coating material, should it be a weak reflector, strong reflector? At this point, you know that we are going for M lah. Okay, so you want to have a strong reflector. Okay, so strong reflector would be produce better reflection. Okay, or a sharper image. This also can. Okay, produce a sharper image. So ultimately, we're going for the M. Don't forget how to write the 9th and the 10th mark for this question lah. Okay, diagram 9.3 shows a safety mirror in a grocery store. Okay, explain how an image can be formed on the mirror. 3 marks. Is the type of mirror, sorry, if the type of mirror is replaced with a concave mirror, what changes will happen? So let's talk about the explanation first. Okay, the explanation will be like this lah. Okay, the light ray that is parallel to the principal axis reflects from the focal point of the mirror, which is this one. Okay, this particular light. This is the first explanation lah. And the second one is the light that passes through the center of the curvature of the mirror. So that's the second light, okay, which passes through the center of the curvature of the mirror. And then after that, the image is formed at the intersection between both light rays. Basically, this question is asking you to answer or to explain, okay, the drawing that you were doing just now. Now, if the type of safety mirror is replaced with a concave mirror, as we said just now, what are the changes that can happen? Of course, when you change it to concave mirror, we think for concave mirror, what happened? The field of vision becomes smaller and the images become magnified. Okay, and actually not just magnified, it also becomes inverted. Okay, so the two answers for this lah. Okay, small vision, for small, the field of vision becomes smaller. Okay, that's change number one. Change number two is that the images become magnified and or inverted. Okay, you can mention one, you can mention both. I think it's okay lah. Okay, it's okay to mention one or mention both. Okay, let's go to the next question. So diagram 11.1, 11.2 shows two identical objects, different positions in front of two convex lenses with the same focal length. Notice that this is question C, part C. So we're obviously looking at the modification question lah. Okay, so we talk about the modification question. It will come with a compare and relate question. Okay, so this is the first situation. This is the second situation. Okay, if you take a look at this, this is U is more than 2F makan. And what's the image? Is red. Okay, but the color this is U is in between 2F and F. And F is less than U, and so this will be rim. Read, raise, rim, boom, boom. Okay, so don't forget that. So, what is the meaning of the focal length? The focal length is the distance between the focal point and the optical center, okay, of the lens. Now, the key word that must be in is the word optical center. A lot of people always forget the word optical center, okay, because for some reason or another. So, optical center is very important, not just the center of the lens, but optical center. Okay, now based on diagram 11.1, compare the object distance, the height of the image form, and the thickness of the lens. So first of all, let's talk about the object distance. So obviously 11.1 is bigger than 11.2. Okay, and then secondly, of course, don't forget I write in full sentence lah. Okay, the height of the image form, we notice that the 11.2 is bigger than 11.1. Okay, so height of the image will be 11.1 is smaller than 11.2. I always like to start with 11.1 first so that I can see the direction of the arrows lah. So that tells me the relationship. Now the thickness of the lens, if you take a look at the lens, okay, it's actually the same lens lah. Okay, and then of course this word tells us lah, two convex lenses with the same focal length. So the thickness of the lens is the same. Okay, so relate the object distance with the height of the image form. Now, if you take a look at these two directions, they're different. The object distance and the height is different. So the bigger the object distance, the smaller the height of the image form, or the other way around lah. Okay, name the light phenomenon. We spoke about this in the previous question. This is refraction. Okay. All right, diagram 11.3 shows a jeweler using a tool which consists of a lens to see a gemstone. Okay, and so explain how a magnified image of the gemstone is formed. Now, a magnified image, okay, of a gemstone, notice that he's putting the object very near to the lens. So we're talking about a U is less than F situation, okay, which is this. U is less than F situation, boom. Okay, so of course you need to start off with the drawing lah. Okay, there's really no other way than to do the drawing. So the first thing you do is you do a lens like this. Okay, then of course you mark the F. You just mark about maybe 5 cm or something, or 10 cm also can, but whatever it is, the object must be positioned over here. And then you draw the diagram as if you would draw a normal one. So the first one is parallel and then cuts to F. And then the second one is goes through the center of the lens. Okay, and then when you extrapolate to the back, okay, what you will get is you will get somehow it will yeah, somehow it will be like this lah. Okay, actually it should be a dotted this one because it's a virtual image. Okay, so this will give you maybe about 1 mark, okay, to show how this is. But the explanation for this, okay, so the explanation for this, let's try. Okay, number one, okay, first one is a convex lens is used. Okay, a convex lens is used, and the object distance is less than the focal length. Okay, essentially U is less than F. Then you talk about the two light rays. Okay, the first light ray is the ray is parallel, okay, to the principal axis and refracts through the focal point, sorry. Okay, so we're talking about this, the green color one, parallel and then refracts through the focal point. And then the second one is the one that goes through the optical center. Okay, a second ray passes through the optical center of the lens. And then finally, explanation will be how is the image formed lah. Okay, the image is formed at the intersection of the two extrapolated light rays. Okay, extrapolated means yang bahagian yang di belakang ni lah, yang dikasih panjang pergi belakang. Okay, so the intersection between the two light rays will give you the formation of the intersection. I guess if you want to put another point, this is really going way above beyond lah. You talk about the characteristics of the image lah. Okay, the image form is, okay, read, boom, boom. Okay, the last one is boom, so virtual, upright, and magnify. Okay, this is a very complete explanation together with the drawing lah. Okay, so if you can take a screenshot, this is the time to take a screenshot. Okay, let's go to the next question. Now, diagram 11.4 shows a convex lens going to be used as an eyepiece lens to pair with a lens as an objective lens. Okay, so you have the eyepiece lens, but you need to look at the objective lens. So explain the suggestion of the objective lens to be used, and the modifications need to be done to build a high-power astronomical telescope. So your answer should include, okay, let's take a look. This is the first one, the type of lens, number one, the focal length of the lens compared to the eyepiece lens, okay, number two, the magnitude of linear magnification, 3, the distance between the objective lens and eyepiece lens, 4, finally the diameter, 5. So the 5 features are given. Okay, so you don't really have to think about it lah. Okay, type of lens. Type of lens is obviously convex lens lah. Okay, we don't use concave lens. So the reason for the convex lens is to focus the light. Okay, or because it's also known as a converging lens. Okay, a converging lens, it converges, so it's a focus length. Okay, second one is the focal length of the objective lens compared to the eyepiece lens. Now, this one you must remember, since the objective lens is, the eyepiece lens is facing the eye. Okay, wow. Now, the objective lens is facing something that is very far away, the star, the moon, the sun. I mean, something very far away. So, the objective lens must have a bigger focal length, okay, compared to the eyepiece lens, small focal length. Okay, so the focal length of the objective lens is bigger, okay, than the focal length of the eyepiece lens. Okay, now why is this? So this is this this is a very standard one lah. Okay, to produce a big linear magnification. Okay, to produce a big linear magnification, because what happens is the objective lens is going to make the picture smaller and the eyepiece lens is going to magnify it. Okay, kind of like what this is happening lah. Okay, so the eyepiece lens serves as a magnifying glass for an image that has been made smaller by the objective lens. Okay, so the objective lens, when the light comes in, the image form is very, very small compared to the star, the actual size of this one. And the eyepiece lens just makes it bigger. So when you have these two things combined, you generally get a bigger linear magnification, okay, because of the eyepiece lens. Okay, number three, the magnitude of linear magnification. So the linear magnification, so that must have a magnitude of bigger than 1. Okay, because if the magnification is 1, it's very sad lah. Okay, so the reason for this, okay, the reason for this, okay, is so that the final image is magnified. Okay, or yeah, betul. Okay, the final image is magnified. So again, remember, let's say the moon lah. Okay, let's say you want to take a picture of the moon. Once it passes through the objective lens, the moon is going to appear very small over here. Okay, very, very small. So the purpose of the eyepiece lens is to magnify this very small moon image so that when it forms somewhere behind here, it will look much bigger. Not as big as the actual moon, but big enough for us to see whatever details that we want to see there. Okay, so the objective lens makes the image smaller, and the eyepiece lens makes the small image big enough for our eyes to see. Okay, fourth, the distance between the objective. Okay, this is a standard fact. The distance, okay, must be equal to the focal length of the objective lens plus the focal length of the eyepiece lens. This is a very, very standard answer. Okay, the distance must be exactly equal to the focal length of the objective lens and the focal length of the eyepiece lens. So in the case of the drawing, okay, I really hope you don't have to draw lah, but if this is the focal length for the eyepiece lens, this is also the focal length of the objective lens. Let's say the objective lens here, right? This is the focal length of the objective lens. This is the focal length of the eyepiece lens. Okay, and there is the overlap must be there. Okay, as opposed to the microscope. Microscope is like this, right? Okay, microscope, the FE is bigger than FO. Okay, but having said that, the distance between the two lenses is bigger than FO plus FE. Okay, so the distance is bigger than FO plus FE. Okay, the FO and FE cannot overlap. They cannot overlap one another and they cannot cross one another. Okay, so the distance between the focal length of the objective and the eyepiece lens, okay, must be more than FO plus FE. Has to be far apart. Whereas in the case of the telescope, is ngam FO plus FE. Okay, and the reason for this, and this is a very standard answer, the reason for this is called the normal adjustment. Okay, under the normal adjustment, the image can be formed at infinity. Okay, this is under normal adjustment. Okay, finally, the diameter of the objective lens, same as just now when we were doing the mirror. The diameter of the mirror must be big. The diameter of the objective lens is also big. Okay, why? Okay, so in the case of the mirror is for a brighter image to be formed. In the case of a lens, it's so that more light can enter. I mean, you have the same reason lah, it's brighter image lah, but for lens is a little bit nicer sounding. Okay, more light can enter the telescope. Okay, so with these two light questions, I hope that we have covered quite a lot of ground lah. Okay, there's mirror and then there's of course lens. Okay, and lens, most of the time we find that a question that is very commonly asked is astronomical telescope lah. But I think if you have time, okay, to go through the microscope, I think it's also a good idea lah. Okay, what I've done here is just to show you the basics of the microscope. But if you have time, go and read up on the microscope because it may be a possible question as well. Okay, let's move on to the next question. So the next topic that we're going to cover is pressure. Okay, there are 3 questions in this set. So the first one is from Malacca. Okay, diagram 11.1 shows an activity that studies a simple hydraulic system in the physics lab. Okay, so whenever you talk about hydraulic system, of course, the name that you need is Pascal lah. Okay, Pascal's principle. So what is a hydraulic system? Okay, so a hydraulic system is a system that uses fluids, okay, not necessarily liquid, but fluid, bendalir lah, okay, to transfer pressure. Okay, based on Pascal's principle, pressure is transmitted. Okay, so the one that is being transferred is pressure. Now, based on diagram 11.1, compare the surface area of piston of syringe A and syringe B. Okay, this is number 1. Number 2, the force acting on the piston. Number 3, the pressure. And then 4th is relate the surface area with the force. And then 5th is the name of the physics principle. Obviously, the physics principle will be Pascal's principle. Okay, because this is the only time that you will see hydraulic system. Okay, so Pascal's principle. So let's talk about the surface area of A and B. Okay, surface area of A and B. Look at the size over here and the size over here. Obviously, A is smaller than B lah. Okay, for the surface area. Now, the force acting on this one, okay, since the surface area is small, okay, and surface area of B is big, if you remember the pressure formula, pressure equals to force over area. So there's a relationship. Pressure is the one that maintains throughout. So AP equals to F. When the surface area increases, the force also will increase. Therefore, the force also has the same relationship. Okay, sorry, same comparison. A has a smaller force than B. The third, pressure on the surface of the water with syringe A and syringe B. Now remember, in Pascal's principle, pressure is constant. So the pressure doesn't change, but the force changes. Okay, so the pressure in this case will be equals. Okay, now relate the surface area with the force. Now we've already done this. The bigger the surface area, the bigger the force. Okay, surface area comes first and then the force lah. Okay, so there you have it. Okay, the 5 marks are there. Okay, next question. Diagram 11.2 shows a chair for dental treatment. So explain how this chair can be lifted up. Again, we have to use Pascal's principle. Okay, so point number 1, the pedal is pressed down. Okay, and exerts a pressure on the liquid. No, not liquid, fluid. Okay, so the pressure on the fluid is transmitted, okay, or transferred, okay, equally or uniformly, okay, to the big piston. Okay, the big piston is the one that's over here lah. Okay, and then finally, the pressure will produce a large force on the big piston. And then finally, the force will lift the chair up. Okay, let's move on to the next question. So diagram 11.3 shows a hydraulic brake system in a car. It's a car system, which is pretty normal. Now, using your knowledge of hydraulic systems, suggest and explain the modifications that need to be made to make the brake system work more efficiently. Okay, so you are given a few properties of the brake fluid. One, size of the piston. Two, type of material used for the transmission pipe. Okay, so this is quite a standard question lah. Okay, now the brake fluid, this is specifically asking for properties. Okay, so you cannot mention that the brake fluid is like oil. Okay, generally brake fluid should be oil, and the reason for this is it doesn't form air bubbles. Okay, it doesn't form air bubbles easily, but they're not asking us for the specific brake fluid. They're asking for a property of the brake fluid. So be very careful with this. So for the brake fluid, I would say that it needs to have a high boiling point. Okay, because this is a very important thing that needs to be at the brake fluid. Why high boiling point? So that it doesn't evaporate easily. Because if you use water and you know that the car system is very hot, the water is going to evaporate very easily, and that's not very good. Okay. Another thing that the brake fluid should have is low density. Okay, kind of like oil. Okay, and then of course, low density usually brings the meaning of lighter. Okay, although I'm not really sure what's the difference with water, but generally low density liquids are lighter. Okay, the size of the piston. So, if you follow the discussion since the beginning, the main piston, the master piston usually has a small size. And then, of course, the secondary piston has a much bigger size. So that will be 0.3 and 0.4. Okay, the master piston has a smaller surface area. Okay, and the reason for this is to produce greater pressure. Okay, and then the fourth one is the secondary piston. Okay, is it called second piston? Or second piston, not secondary piston. Second piston has a bigger surface area because according to the comparison question we did just now, the bigger the surface area, the bigger the force, okay, to produce a greater force. Okay, and so this 0.3 and 0.4 are kind of standard okay, in any hydraulic system, especially when you want to exert a great force. The master piston has a smaller surface area to exert a greater pressure, and the second one has a bigger surface area so they can produce a greater force. You can lift whatever car you want out, you can press the brake much easier, and etc. etc. Now, finally, the type of material used for the transmission pipe. Okay, so the pipe are not the brake fluid. So the pipe, okay, the fifth one is steel. Okay, we are going to use steel for this Usually it's steel Okay, anyway, and usually we use steel because it's stronger, it lasts longer, all the standard answers Okay, not easy to break, B-R-E-A-K, okay, can withstand high pressure, okay, somewhere along those lines. Okay, and that's how these are very standard answers for hydraulic brake system. It's pretty easy question if you know your Pascal's principle well enough. Okay, let's move on to the next question. Diagram 11.1a and 11.1b show water spurted out from holes at the bottom of the tin filled with water. And so this is probably a liquid in pressure situation. Okay, so what is meant by pressure? Pressure is force per unit area. Okay, based on diagram 11.1a, 11.1b, compare the depth of water and the distance. So the depth of water, okay, which is H and H, so obviously it will be 11.1a is bigger than 11.1b. Okay, the depth is much bigger lah. Okay, the distance, look at the distance over here and the distance over here. So we have the same comparison again. So the distance is 11.1a is bigger than 11.1b. Let's state the relationships between the depth of the water and the distance. So since it is the same direction, okay, so you have the bigger the depth of the water, the bigger the distance. And then you deduce the relationship between pressure and water velocity. So the bigger the pressure, the bigger the water velocity. Okay, this is quite standard, quite easy, this question. Okay, 11.2 shows a wooden cube afloat on the surface of olive oil and water. Okay, so look at the difference. Explain why the wooden cube is less afloat on the surface of the olive oil. Okay, so this is a 5-mark question. Okay, so number one, when you talk about floating, always remember the most important point is that when the object floats lah. Okay, when an object is floating, the weight of the liquid, okay, displaced is equals to the weight of the cube. Okay, the wooden cube lah. Okay, this is the most important thing. The weight of the entire cube itself is equals to the weight of the water displaced. Okay, once you've established that the weight of the liquid displaced equals to the weight of the cube, okay, and since both situations have the same weight of the cube, so you can also say that the weight, okay, or the mass lah, okay, of the oil displaced is equals to the mass of the water displaced. Same displacement because it is floating. Okay. Thirdly, once you've established that, of course, you need to say that the main difference here is actually the density lah. How does the density affect this one? So, mass equals to density times with the volume. Okay, so number 4, since the mass is the same, therefore, when the density is high, okay, in terms of the water, okay, the volume is low. Okay, less water is the volume of water is the mass is the same, okay, but the less the the volume of water displaced is low, and so that's why the wooden cube, okay, floats on water. Okay, so coming back to the buoyant force, this is buoyant force situation now. Buoyant force is the density times with the volume times with the gravity. F equals to rho Vg. I think the most important thing that we need to understand is when an object is floating, the weight of the liquid displaced is equals to the weight of the whole cube itself. And because of that, okay, and since the weight of the liquid displaced is also it is equal in the sense because in both situations the weight of the olive oil displaced and the weight of the water displaced is the same. Okay, and so when we take out the g, okay, because rho v is actually m, okay, mg, weight of the water displaced is actually mg, but we can write the m in terms of rho times v. Okay, the mass equals to the density times the volume. And so we find that since the mass is the same, what changes actually is the density and the volume. When the density is high, the volume of the liquid displaced is low, okay, which makes the wooden cube float on water because it is actually displacing less volume, same weight, but just less volume. Okay, and that's why it floats on water. So this is a little bit funky, because it's hard for us to grasp that sometimes that mass and volume are two different quantities altogether. The mass of the water displaced and the mass of the olive oil displaced is the same. It's the volume that is different because of the difference in the density. And the volume is the one that determines whether it floats or sinks. Okay, let's move on to D. So D shows the hydraulic brake system of a vehicle. Once again, a hydraulic system, same as the previous question that we were talking about just now. Now, using physics concepts, talk about the size of pistons, material for the cylinders and the pistons, type of hydraulic fluid, and other properties. So it's pretty similar, lah. Okay, so the size of the pistons, talk about the main piston and talk about the secondary piston. Okay, so of course, the main piston, which is P1, okay, is a much smaller piston. We talked about this in the previous question. The P2, the secondary pistons or the wheel cylinder pistons, okay, are the much bigger pistons, lah. Okay, and the reason you can actually mention it there just now. Now, for the cylinder and the piston, slightly different lah. Okay, when we talk about the cylinder material use, we can talk about the characteristics of material or even the specific material itself. Cylinders usually are steel, okay, because or steel, or you can also say a strong material, okay. And the reason for this is, can withstand high pressure, okay, or you can also say doesn't rust easily. Okay, either one is also fine. For the piston, okay, you can also actually use the same, this one lah. Okay, it can be strong, it can be steel, okay, but again, the piston is supposed to withstand a high pressure. Okay, that's of course the main thing lah. Okay, but you can also say it doesn't rust easily, it lasts longer. Okay, different reasons, but essentially it's the same. It needs to be able to withstand the high pressure. Okay, now let's talk about the hydraulic fluid, the type. So specifically the type, of course, we have to talk about oil. Okay, the type of hydraulic fluid should be oil. Okay, and then the main reason is because difficult, okay, to form air bubbles. Okay, difficult to form air bubbles. Another one is, since we're talking about type of hydraulic fluid and properties of it, so I guess you can also talk about the high boiling point, low density, okay, and all these particular reasons, okay, which we mentioned in the previous question. Okay, now another thing that somebody wrote over here, okay, is that the size of the pipe. Okay, the size of the pipe or the diameter of the pipe, okay, is small. Okay, so which is actually for this lah. Okay, the size of the pipe is small so that it can produce a big force. Okay, I'm not really sure whether this comes under other properties, because I'm not really sure whether it's other properties of the hydraulic fluid or other properties of the entire system. I think it's the other properties of the hydraulic fluid lah. Okay, but in case you have space and you can still write some more, you might as well write about the pipe itself lah. Okay, so it's a very similar question to the one that we were talking about just now. Okay, let's go to the last question in this set. I believe it's the last question. Okay, so 10.1 shows a gas balloon moored with a load. Mass of the balloon and the load are 5 and 20 kg respectively. Balloon and the load float at a certain height, air resistance is negligible. When you talk about the word floating, obviously we're talking about Archimedes principle. Okay, so what is the meaning of density? So density is mass per unit volume. Okay, explain why the balloon and the load float. So this is the explanation. Most importantly is why the balloon and the load float, okay, is because the buoyant force is equal to the weight. Okay, so first of all, talk about the force on the balloon. The force on the balloon weight, which goes down, and the buoyant force, which goes up. Secondly, relationship between buoyant force and the weight is equal. Flotation situation. Okay, and this causes a zero resultant force. and zero resultant force means that it will float lah. Okay, it will neither go up nor go down. Okay, and of course here we talk about Archimedes principle. Actually, not just Archimedes principle, Archimedes and flotation principle. Okay, prinsip pengapungan lah is applied in this particular situation. Okay. Right, referring to diagram 10.1, calculate the buoyant force acting on the balloon and the load. Now, if you understand this correctly, okay, you will know that when you calculate the weight, you are already calculating the buoyant force, because in a flotation situation, the buoyant force is equals to the weight. Okay, and so don't be trapped by, oh, okay, I have to use the buoyant force rho Vg. I have to find the density, I have to find the volume, which is not given to you at all. Okay, this question is designed to see whether you understand the concept of buoyant force equals to weight. If buoyant force equals to weight, when you count the weight, you will already have gotten the buoyant force, which is 245.25 newtons. Now, if the mooring rope is cut off, the balloon will rise up, obviously, because the buoyant force is bigger than the weight already lah. So the buoyant force remains the same. Okay, so you calculate the acceleration of the balloon. So this one we will have to use F net equals to MA situation lah. So the net force is buoyant force minus the weight, which is here. Okay, equals to the mass times acceleration of just the balloon, which is 5. Okay, so when you do this calculation, replace the buoyant force 245.25, the mass times the gravitational acceleration 9.81, you will get the acceleration upwards, which is about 39.24 meters per second squared. Okay, diagram 10.2 shows a nuclear powered submarine. A nuclear powered submarine is to be built, table 2. So of course you want to analyze the table lah. Okay, so the half-life of the fuel should be a long half-life. Okay, long half-life means, and usually long half-life, the answer will be, you don't have to replace so often lah. Okay, sorry, it's not written over here. Okay, so long half-life. Okay, a long half-life means that you don't have to replace so often. Okay, it takes a longer time to decay. Okay, doesn't have to be replaced often lah. Okay, so we have a big half-life, long half-life, so that you don't have to replace it so often. Okay, it doesn't have to be replaced too often, or it takes a longer time to decay. All these are valid reasons lah. Okay, now the shape of the submarine, okay, should be hydrodynamic lah, not hydrofoil. Hydrofoil is actually to do with Bernoulli's principle, not really to do with submarine. Okay, so hydrodynamic, and the reason is to reduce water friction. Okay, just like an aerodynamic shape, okay, is to reduce air friction. Another word for hydrodynamic that we often see is the word streamline. Okay, streamline over here, dalam bahasa Melayu is bentuk larus lah. Okay, so all these are similar words which used to describe submarine, the shape of ships, yachts, okay, etc. Now the size of the ballast tank, okay, should be big. Okay, so that when you have a big ballast tank, you can have a big buoyant force lah. Okay, or yeah. So when you have a ballast tank, remember the ballast tank is for the water to be pumped in or to be pumped out. When you pump in the water, the weight of the submarine increases and it gets to sink. When you pump out the water from the ballast tank, okay, you get to float. Okay, because the weight is reduced and the buoyant force still remains the same lah. Okay, and finally, the rate of rusting. At this point, you will know that we are going for the answer V. Okay, the rate of rusting should be low, and general answer for rate of rusting will be it lasts longer, does not rust easily, etc., etc. Okay, remember that a low rate of rusting means it takes a longer time to rust. Okay, I think I mentioned in the previous video, rate and time don't work the same way lah. Okay, a longer time means a smaller rate. Faster time means, shorter time means bigger rate. Okay, so once you have this, you will have the answer V. And again, don't forget the 10th mark. Okay, so I guess that's it, okay, for this video. In the final video, we will discuss the rest of this module. Okay, I'll see you in the next video. Take care.